Okay, so we are going to see some tire dynamic models, and using these tire dynamic models as a motivation for us to learn working model 2D. So as you can see, the expressions of the damping coefficients are have been obtained experimentally, and they have several parameters to deal with. But from our purposes, right now, what I think we need to do is to recognize the kind of elements that we have. In this case, we have this is in the mass of the rim or car in this case, some spring and some damper. And the other one is a combination of the damper and the spring also, but the spring being also on the other side. So what I would do is let's do an experiment. Given this model, what will happen if you drop the vehicle or drop this tire onto the ground? So let's take a look at both of these models and see if we can get this kind of a response. Okay, so why don't we follow this, and let me go over and see if we can get the software to work. There you go, working model 2D. Go working model 2D in here, click on the software, and then you're gonna see. So let's just keep our original model on the left hand side, and my objective is to build this one on this here. So when you click working model 2D, you will come with a set of icons at the top and some icons on the left hand side that would allow us to build the different connections and also build different rigid body configurations. So what we want is this one. It will simulate the mass that we have in there. What I want you to know is when you work with working model 2D, what you draw on the screen is really not a drawing, it is a representation of a rigid body. So if you click twice over here, see what it has? It has, of course, the positions in here. It has the orientation about the X and Y axis. And then you have the initial velocities, and also some rotational velocity that could be an initially given to this. It has the mass in this case, and then the coefficient of static friction, the coefficient of kinetic friction, and this one is the elastic coefficient, or also known as the coefficient of restitution, which was presented in first dynamics class. When you study collisions, you study the coefficient of restitution, which is actually controls how much deformation you have for in a collision. Charge does not apply and the density does. Okay, so all right, so I'll just close this one and I'll say, oh, okay, I need to build another system. Well, although this combination could be built over here like this, see, one thing about working model 2D, it has some sensitive spots on each body See, this is the center of mass in here. And this will be the center of this. And then, see, it has different, but it uses so that you can actually attach to the ground, like in this case, if you do the C, you'll build a system like that. And this would be one model like that. But we could, if we want to, build it this way separately. Okay? And to do that, we need some sort of a we need some way to build a connection, okay? And we can make this massless, but we needed to build a connection if you have it in here with this, see? And then we also will have the damper, which is over here. And this is just like the one that you see. And then, of course, you could actually make this fixed. If you anchor this, yeah. What do you think? You think it'll work? Should I click on run? No. First one, we need to fix this one. There you go. You put it so that it won't move. Now let's see what happens. Bad engineer. We need to do something better. Why is that? You know, the body has the inertia, of course, and it is free to move in X, Y, and also rotate. So it has those 3 degrees of freedom. But we could actually make it that they would go on a slot. So we could say, okay, this is a slot element. Depending on how we make it connection in here would be key the slot joint. So I would do this, and if I put it in here, see, then the system is going to move along this line, and chances are will produce what we want. See, there you go. Okay, is everybody following me? Can you? Yeah. There we go. This is as is. So one thing we can do is we are going to track the motion over here, and if you click in here and you say measure the position, you can measure X, Y, as well as the rotation graph. So let's just do this. So in here you have this, and we'll see where it goes. Yeah. So now we are going to say, okay, run, and see what happens. No rotation graph. What did? Okay, hold on for a second. I think we need to. Sorry, let's go back here for a second. Measure position, right?
Ours won't allow us to do it.
Okay. Let's give it a try. There you go. See?
Yeah. Why is ours grayed out? You know why?
Okay, so now we are going um, to see if we can reproduce the one on the right hand side. So let's move it a little bit to the right and see if we can modify ours. And here we're gonna what we would need to do is to change this, but well, let's try just the individual elements and see where we go from there. And then we need the other one, this one, to go from here to here. Let's see if we successfully did that, although it's the reverse. I want to make it exactly like we have it. So why don't we go this one over here, like this, and then we'll go from here to here, and we're going to make an attempt to connect the other one also. So from there to here. We'll see. Let's try to see how this will work. Yes and no. I am not sure that these two are working the way it should. So we might need to do a little tricking here. See, this is not very well attached. So what I'm going to do is I am going to build just a tiny little piece that is going to be used just for connection. Okay, and in this case I will attach this to this. That will work. And then I can attach the spring. But in this case, you see they are not connected in the air, but they are connected with the body. And that's why I believe this one will actually work if we do this. Let's give it a try. Yes, because now you can see the spring is also working. See? Oops. Now we are learning something. Not good engineer. In these things you have to be careful. That thing is also going to need a slot joint. Yeah? Because otherwise it's not representing what we want. Although it is a system, but not the one we want. So what I would do is we'll do another restriction over here. Right there. Let's go run it now. There you go. Now I think we have it working really well. What I think I still would like to see some other effect. We need to stiffness this. This is 1. I am gonna make this a 10 and see what happens. Okay, let's run here. Still is, compared to the spring, is, although the damping increased so much that there's hardly any oscillations now. Do you see what happened? Maybe the spring is just too strong here. This one in here. I am going to lower this to maybe 20,000 newtons per meter. 20,000, yeah, like that, right? So let's See, now this stiffness is way too high. But I think we can play around with the different responses until we get the one we want. But this illustrates what we can do with this.